Welcome back, everybody. I'm glad you can be here. We're having to be talking about calculus, and we're looking at the limits and evaluating them analytically, and we're over here in this section. Ooh, that's hot. Or is it cold? All right, we're looking at the composition of two functions and taking the limit. What do we got here? We got the limit as x approaches 20 of 9 times g composed of f of x. So let's try to remember what this says here, because I'm going to have to rewrite this. 14x minus 3. 14x minus 3, where we're at right here. We got, oh my god, I already forgot, f of x. We got f of x is equal to 14x minus 3 g of x, 2x minus 8, and we're taking the limit as x approaches, I think that was 9 there. Alright, x approaches 20. Okay. X. Now, in this section, we've stated this. There was a theorem that we stated quite a few times about just taking the limit of a composite function here. But what we've got is a scalar multiple. All right, we got this 9 here, and what we could actually do with this 9 is we could just bring it over here to the left and get it out of the way. And I'm going to do that as x approaches 20 of g composed of f of x. Now, in this particular theorem that was stated in some other problems, I'm not going to rewrite that thing again, but basically what it says is, it says here that we could take the limit of this inside function. So for example, the limit as x approaches 20 of f of x, and we can get that number, okay, and that's actually considered to be L in our theorem. We could get this number, and that's what we're going to do, and then we're going to take that number and just plug it into g of x, and that will be what our limit is equal to. However, remember, we still got this 9 out here. Okay, so we don't want to forget about the 9 here. All right, so let's go ahead and do that. Let's just do that. Okay, so we have the limit as x approaches 20, and we have 14x minus 3, and so we do the direct substitution. We have 14 times 20 minus 3. All right, let's get that real quick. 14 times 20 minus 3, and that's 277. All right, 277. Okay, and then we can take that 277 and plug it in here. 277, and so that becomes 2 times 277 minus 8, and let's do that. So 2 times 277 minus 8, and we get 546. We get 546. All right, so have run out of room here. 9 times, so this limit right here, okay, all of this is 546. And we times that by 9, we get this big number, 4914. And let's hope that that's it. Yes, it is. And of course, I've got the help here explaining exactly pretty much the same thing what we did. We took the limit of that first function, plugged it in, and then multiplied by 9.